welcome here and thank you for joining this edition of the OpenSIPS Summit. We are proud to be at the third edition. It's something quite new. We had roughly 1 year ago the first edition of the summit, and I want to thank a couple of people from the OpenSIPS Foundation for helping and contributing with this, like Ali Bey, Flavio, Alex, for contributing with their effort in order to organize this event. So now to introduce myself, my name is Bogdan-Andrei, and I'm the founder of OpenSIPS project. And I will, let's say, entertain you for the next 1 hour. I hope it will not be a boring 1 hour. Telling you a couple of things about OpenSIPS, and then about our new release. And then we will continue, let's say, more interesting things, more interesting in the perspective that we have several valuable speakers who share with us their experience in regards to OpenSIPS, like what kind of things they did. And yeah, there will be some quite interesting stories to listen to. Before starting, also to thanks to our major sponsor for taking care of supporting this event in terms of paying for the room and all other expenses. Because at the end of the day, we are an open source project, so we don't have our own revenues. We rely on people helping us with different kind of in whatever they can, time, work, paying for different kind of things, and so on. So once again, thanks to Michael for investing into the summit. Unfortunately, he had some last minute traveling to do, so he was not able to show up today. So it's a bit surprising, but you know, that's life. So moving on with the actual presentation. Just to be on the safe side, I will start with a couple of words about what OpenSIPS is as, let's say, software project, whatever you want to call it. But before doing that, out of curiosity, like how many of you have an idea about OpenSIPS, or let's say there are any like new people who just heard about it without actually, let's say, getting in touch? So they are fresh people, or everybody had some experience? Never? Yeah. Okay, I'm just trying, so...
I've played it with installing it, but I really haven't got it up and running yet.
Okay. I'm just trying to figure out, like, all the time we had a debate, like, should we get into, like, what is OpenSIPS and this kind of things, like, or simply jump to the more interesting things. So that's why I wanted to see, like, how many completely new people, I mean, new to OpenSIPS.
So raise your hand if you're running OpenSIPS.
Sorry?
Raise your hand if you're running OpenSIPS.
Yeah, let's see.
All right.
Just to see.
So
Okay.
half of us.
Okay, so yeah, that's so you are more like interesting, like what other things you can do. But you have your own experience, you want to see other people experience on that. Okay, so for the people who never tried yet, just using OpenSIPS, just a couple of ideas like what OpenSIPS is intends to be. And in short terms, just remember that primarily is an SIP proxy. So basically, whatever we do, we are talking about SIP into OpenSIPS. We are not talking about RTP media. We are not talking about HTTP. We are not talking about anything else. So the main focus is on the SIP protocol. And I said primarily, so not only SIP proxy, because at the end of the day you can say it's a multi-purpose proxy. It's in terms of being able to do a lot of things with SIP. So it can act as a simple register, it can act as a simple, let's say, router for the traffic. It can act like a presence server or as a load balancer, back-to-back user agent, whatever. So there are a lot of functionalities present into OpenSIPS. It's up to you how you want to use it. So basically when it comes to SIP, you say yes, OpenSIPS is the right tool to do, and you just have to do the proper configuration to have it doing your job. And talking about SIP, we are trying all the time to cover all the flavors of SIP, so not only about calling the voice part. You can do the presence, you can do instant messaging and any other, let's say, new extensions of SIP, because the IETF guys are never sleeping about that, so they come up with all kinds of crazy ideas. So we never get bored about, we are done. All the time there's something new to be added. And because of that, let's say the natural place of OpenSIPS in a SIP network is, let's say, somewhere in the middle, talking and exchanging traffic with all the other SIP applications, starting from endpoints, maybe other switches, or maybe with media servers and so on. Why we get, let's say, this central point in the network? Mainly because OpenSIPS has like three important capabilities. First, it's about the throughput, so you can really put a lot of traffic on top of it, so you can handle a large amount of traffic. Then it's about the flexibility, so it's more or less like programming. You have a very simple language where you tell OpenSIPS how to handle the traffic, so there is nothing hard-coded or just make it work. You have to configure, so you can actually create whatever kind of a setup you want. So you are not limited, like choosing a couple of options. You have to configure, so you can describe your own logic what awaits that. And also you have a quite impressive collection of modules in terms of providing different kind of small functionalities already available on OpenSIPS that helps you in, let's say, achieving this flexibility. So you can look at the script, like a way of putting together different kind of small bricks, which are provided by these 134 modules right now in the latest release. And they are modules providing you with the connectivity to the, let's say, the ability to connect to the databases, SQL, NoSQL, or modules which are more like SIP related in terms of doing special kind of routing, or modules in terms of routing, doing LCR or balancing and so on. So different kind of modules for different kind of functionalities. The idea is you have them available, then you can combine them into the script, and bingo, you get ideally what you want to. So these are the main stronger points of OpenSIPS. So basically, based on that, you can go in two directions. So either if you want to do something, you have the case where you need to handle a lot of traffic, or if you want to go into the other direction, like you have something really, really complex, like logic to implement. In both cases, OpenSIPS will definitely help you with that. Couple of words about the actual project. So probably it's well known for everybody right now that it's an open source, GPL licensed project. We have quite a large community of contributors, active contributors. providing writing modules, providing patches, contributing in terms of, which is sometimes one of the most important things, like reporting bugs, fixing, and so on. So, you know, taking one at a time, it may look like a very simple thing, but actually they are one of the most important things to help you with testing, with reporting bugs and fixes. Community is quite, at some point, difficult to track, like number, you know. It's exactly like someone asked me a couple of days ago, like, how many people are using OpenSIPS? Well, how do I know that? How should I know that? Because it's, you know, it's a free software you can download. You can download it via several channels. I mean, you can get it from like packages from directly from different distros. You can get it from the Git repository. You can take it as a package, and you know, the tarball sources from a web page. So it's quite difficult at some point to keep track of all of them and to say, yes, I don't know, we had like some number of downloads per month or per week. So it's quite hard for the open, that's not particular for OpenSIPS, it's probably for all open source projects. At some point it's very difficult to keep track of that. And yeah, one of the most important things for the open source project is about what we call the knowledge transfer, because definitely code is for free, right? That's the whole beauty with open source. But the tricky part is about the knowledge, right? So we have different kind of ways to do the knowledge transfer. So basically means you to learn how to use OpenSIPS. And here, starting from simple things like you know, generic documentation, tutorials, webinars, and so on that are available. Support via mailing list, IRC channel, and so on. We also have the e-bootcamp training or certification, successful certification program. When you get certified by the project itself that indeed you have a certain level of skills in terms of using OpenSIPS, because that may help you in, let's say, performing other tasks in terms of configuring for other people or maintaining an OpenSIPS-based platform. Okay, so let's. The interesting part is right now to see. I will talk a bit about the latest release of OpenSIPS, which is 1.11. What is the impact of this release, let's say, overall? Well, 1.11 it's the latest long-term supported release, so it will have a quite long, at least 2 years lifetime. So it's a, let's say, a good version to invest into in terms of building platform on it. And when 1.11 was released, automatically 1.9 became obsoleted, so it could not be maintained. So wherever it's using, you are by your own to that. And 1.8, which is the previous LTS, and 1.10 will still be maintained for like approximately 4 months before also becoming obsoleted. So just to know exactly how the situation is before choosing what release you're going to use into your setups. Now about 1.11. Before actually going into the details, just a couple of words about what's the development strategy of the project, because definitely it's not about, I mean, the development is not like just doing a bunch of things, you know, one day and one day without any kind of, let's say, relation between, you know. And surprisingly, we have a strategy when it comes to, you know, how the things are developed into the project. And you have to take care about 2 things, because in any application you have the low level and the high level application, of course, and the mid level application. Like low level, you have a lot of things about the SIP stack, about the transactions, transport protocols, and so on. You know, things that usually you don't see. They are there, they are doing the heavy work. You are not directly aware of them, but they are there, and they are doing, once again, a quite great job. And then it's about the high-level applications, like when you see, wow, we have least cost routing, we can do balancing, or you can, let's say you can do, I don't know, other kind of crazy things, you know, so things that are directly used by you in the config file. So all the time you need to have a balance between how much effort, development effort, you invest in these two, like low level and high level, and not necessarily because, wow, we like to be consistent and so on, because there is a strong dependency between these two levels. I mean, definitely you cannot build a lot of functionalities if you don't have a strong foundation, if you don't have, let's say, a strong SIP stack, SIP engine, if you don't have all the capabilities in terms of let's say, throughput and so on. You cannot simply just put nice things on top of it and that it can't have mercy, it should work, right? And neither the other way around. I mean, you cannot simply invest all the time in the low level, because low level, how to say, doesn't sell for the end user. I mean, nobody's attracted by the fact that you have a gorgeous SIP stack, but you cannot do anything on top of it, right? I mean, the things which are attractive for the people, for the users, are the high-end features. That's it. So you have all the time to keep kind of a balance between to offer the high-end features, because these are attractive, but at the same time to be able to support them by having an let's say, a strong foundation in terms of stack and everything. So somehow I tried to structure what's new in 1.11 to have a kind of bottom-to-up approach, like what we did on the low level, and also then at the end what we did on the high level part. So starting with the low level, surprisingly there was a lot of work in the memory manager. You may say why it works, you know, but actually in a couple of tests, you know, even basic tests, the memory manager proves to be at some point a bottleneck, because you have an application which is a multi-process application, and you have shared memory between like maybe tens of processes. And at some point, you cannot scale with the number of CPUs or cores you have on the machine, because this shared memory becomes a bottleneck in the whole application. So we did profiling testing just to, let's say, first of all, validate if it's the case or not, and then particularly address the problem. So the result was a completely new memory manager, which is available right now in OpenSIPS. It's called the High Performance Memory Manager. And we had the tests on an IBM series machines. Before this memory manager, we could get like 25,000 scrolls per second in terms of how much traffic we could handle. And with this new high-performance memory manager, we ended up with like 60,000 scrolls per second. Same hardware, you know, same number of processes. It just basically it's about increasing the level of how much you can, let's say, process in parallel and avoid bottlenecks because of this memory manager. So you may say you will not see it when you run OpenSIPS, but it will really make a big difference between, let's say, before and after this new memory manager. Of course, depends on how much traffic you have on your system, but once again, that's something really important. Other interesting aside simply increasing the level of parallelism with the memory manager is the fact that this memory manager can learn in terms of warming up memory. So at the runtime, depending on what's, you know, usage pattern of memory, you can generate a report at the end, and so you can warm up the memory in terms of doing explicit fragmentation to fit your memory usage. So at the runtime, you don't have to go again through all this fragmentation all over again. And this is important because we had cases where you start an OpenSIPS engine, and then you put like automatically 20,000 calls per second into it. So you don't have time to do the, let's say, normal warm-up based on the traffic. The application should be able from time 0 to handle that amount of traffic. And we noticed that this warm-up was really a big problem. Because when you hit, let's say on a cold, fresh started OpenSIPS, when you put like 20,000 calls per second, it will actually take a lot of time and resources to just to do the fragmentation, so basically to, let's say, create all the fragments into memory in order to handle the traffic. So we ended up with this kind of automatic warm-up and startup. So when you put the traffic, everything is prepared to in there. Then there was other kind of optimizations. Once again, what was the target was to increase the level of parallel processing, because that's something important for a multi-process application that wants to take advantage of all resources that you have on the machine. Because it doesn't matter if I have like a 24-core system if my application is not able to properly use them. So basically your application cannot scale with the hardware. So that's something important. And something similar for as we had for the memory manager, we had also in the transaction module. When it comes to some timer processes, I will not get into the details because they are quite low-level technical things. But anyhow, there were a couple of things and kind of a couple of bottlenecks into this transaction layer that were addressed in order to increase the level of parallel processing, and also into the TCP side. Especially when we had this kind of an end-user TCP connections, especially for mobile devices where you have very short lifetime connections, dynamic, in terms of you have a lot of connections set up and termination, and traffic, or quite a lot of traffic. I mean, phones registering every 30 seconds, typical mobile devices. So such a behavior on the TCP connection can really raise problems on the stack, because otherwise for normal, let's say for normal end user, normal hard phone registering over TCP, there's no challenge at all. You can have a connection, you can have like 200,000 connections. Phone registers every 1 hour, connection is up for, let's say, all the time, so there is no challenge. But when you have a, let's say, dynamic behavior, connection setting up and terminating, I don't know how many per second, and a lot of traffic on that, and in that case it becomes challenging. So all these optimizations are addressing this kind of then a couple of enhancements. We tried to make things consistent and easy to work at the script level mainly. The most important was the ability to, so let's say, to drop the global parameters into the modules. There are a lot of modules like defining parameter, a global parameter for which will be then used by a function. Like when you call this function, expect to get some result into let's say a variable which was defined as a global parameter. And that was a bit difficult, especially when you use the function multiple times, because you can get the variable overwritten. Just an example. So instead of using global parameters, we actually pushed everything into as parameters for the functions or not for the module. And because you have a variable number of parameters as number and position, we had to introduce this kind of empty parameters into the script. So just to say, okay, there is a parameter over here, but I don't want to use it for this particular call. Because otherwise, by simply having a simple list of parameters, you will never know which one, let's say, P3 is, if you have a couple of optional parameters. So it's to be ambiguous a bit. So that's why we had to introduce this kind of empty parameter just to have a quite straight order when it comes to optional parameters. Probably you'll see in the script that this simplifies a lot. We had quite problems in a couple of our platforms with these global parameters because you were using a function several times and was overriding one of the variables used for the output. So you have to be careful of that. Other important enhancement was about the persistent state in modules working with, let's say, generic destinations like dynamic routing, dispatcher, and load balancing. Like you're using dynamic routing to do prefix-based routing. You disable a gateway. I mean, you learn about the gateway being down. You disable it from the script. And if you do a restart of OpenSIPS or a reload, then this originally, in the previous version, this disabled state was lost, was not persistent. So when you restart it, the gateway was again active. Well, in 1.11, you have this state is persistent via the database. So it will be written in the database. When you do restart, you will see again that gateway has been disabled. So that will simplify things.
Is that the DB mode would affect that behavior?
It works via the database, so it's writing actually back to the tables where the destination are configured, and you can turn it on and off. There's a parameter you can for that. So if you don't want to have persistence, you can turn it off. By default, it's on. But if you want to be, let's say, backward compatible, then you just have to disable to turn on off. Sorry, that parameter. Because there are cases where such tables may be views on other tables, so you cannot write into that. So we said, okay, let's have the possibility to turn it off also. More, let's say, mid-level interesting things. We had the registration replication between instances. This was possible also in the previous versions, but you had to do it first manually explicitly from the script via the treplicate function. And secondly was done by SIG, which was a bit of inefficient, right? But that was the easiest way in the first version to do that. So right now we have this the binary interface, which was added for the dialog, originally for the dialog replication, so basically two instances replicating between the dialog states. And now we have the support for replicating the registration. So basically, instead of doing it once first in the script and secondly via SIP, now you can do it automatically, so transparent for the script, and it will be done via this binary interface between instances, like replicating registrations between several OpenSIPS instances. So it's much easier and efficient to do that. Probably if you look at this chart, you'll understand what I mean here, right? Because everybody went through this, I don't understand how it works. I don't know what to do next, right? Especially that with OpenSIPS things are even more complicated because first you have to understand SIP as protocol, and then you have to understand how OpenSIPS works. Right, so you have to, let's say, you should do Redis at the same time. And there are a lot of people here in this red area, simply dropping it. Simply don't have the time, the will, or whatever to, let's say, to do the necessary learning. So we said, okay, let's try to fix this, let's say, to help people with the learning curve. And we have in 1.11 this new script helper module. So this is a new module which, let's say, helps you with the learning in terms of hiding a lot of SIP-related things for you. So it's automatically doing them for you into the script. So you can focus in the very beginning in generally learning how OpenSIPS works without really understanding how SIP as protocol works. So instead of, let's say, having the requirement to learn both SIP and OpenSIPS in the same time, first, by using this module, you'll learn them one by one. First, using the module, you'll focus on learning how OpenSIPS works. And then when you are done and you say, yes, okay, I got through that, then you can, if you want to, it's not mandatory, you can drop the module and then dig into details about how the SIP works. You know? Because basically, right now you have to understand, okay, what's the difference between initial sequential requests, how the dialogues should be handled into OpenSIPS, right? And so on. So things which are more or less related to SIP. Well, this module can automatically do that for you. So it will automatically do the handling of the sequential requests, so you don't have to bother to understand all these details, like loop routing, record routing, and all this crap. And also about what's the relation between SIP dialogues, how to create a SIP dialogue with OpenSIPS and so on. So this module can hide all this for you. So let you focus on simply, let's say, understanding and playing with the traffic at high level, right? So ideally, instead of having this kind of curve, more or less you have a straight line, which will be much easier to, how to say, to work with, right? There are plans in the future to add more things into this script helper, let's say, to have the possibility to handle automatically several things, not necessarily only dialogues and sequential requests. It will have incorporate the ability to handle, let's say, registration and authentication in an automatic way, completely transparent from the script, and maybe, let's say, the NAT reversal part, and so on. So it creates an default automatic way of handling them. Whenever you want, you can disable and do it explicitly into the script when, let's say, you get to the level where you say, yes, I master this kind of knowledge and I can do it by myself. Otherwise, the module can do it in the default way for you, so you can focus on, let's say, being able to make a call between two phones. That's, let's say, the first step. On the high end, into 1.11, we have the call center module. Basically, it's a module able to do call queuing and distribution into OpenSIPS. Is exclusively signaling only, so you have to use it in conjunction with the media server, free switch, asterisk, whatever. And it's for an inbound. It's an inbound call center. You have the ability to run multiple queues. You can log in agents with different kind of skills. You can do priority, so you can do a lot of things about how the calls should be distributed. Why do we need the media server? Well, you need the media server if you want to, let's say, first completely separately, you can put in front of it kind of an IVR if you want to select, let's say, the queues based on an IVR, or you can simply do it based on called PIDs. But media server is mandatory, at least for first playing the queuing message, or if you want to play some, let's say, welcome message in the queue. So basically for whatever means RTP injection. But once again, the whole logic in terms of putting calls in the queue, keeping track of agents, like who's free, who's in a call, and so on. Extract calls from the queue and distributing to the free agents and so on. That's done by OpenSIPS itself. And why was the need for that? Mainly because of the throughput. I mean, definitely you can do something like that with, let's say, maybe the free switch or asterisk kind of queues. But when it comes to having queues with maybe tens of thousands of agents, so quite large call centers, distributed with maybe a couple of tens of queues, when you have like maybe thousands of calls in a queue, then it's a really problem. You have a problem. I mean, you cannot simply rely on let's say, on an asterisk, on a free switch to do that, because it simply cannot handle so much amount of traffic. At the end, I will show you a demo. I have actually on my laptop on OpenSIPS installed, and I will show you a couple of using CPP how you can do traffic, like simulating a call center, just to get an idea on how it works. Other interesting things in 1.11, or let's say more like in the mid-level, on the management interface. Management interface is an interface that allows you to talk to OpenSIPS, to trigger things inside OpenSIPS, or to get information from OpenSIPS. So we have a new backend. It's the JSON syntax for the management interface. And the great advantage of this JSON module is the fact that you have you can get what we call a structured output. I mean, the JSON syntax gives you the ability to structure the data inside. You don't have a simple text output. Just to give you an example, like listing ongoing dialogues. You know, if you do it the, let's say the FIFO interface, you get a bunch of text. So you have to interpret then the text to see actually how many dialogues are, to identify the elements from the dialogues. Basically, you have to write a parser to interpret the output of the command via the FIFO. Well, with JSON, you don't have to do that because the whole output is packed in a JSON string, right? So with whatever JSON parser that's available in all languages, then you can unpack it and you can go straight to whatever you need from there. So it's more efficient in terms of interpreting the output of the commands. Then we had the shared call appearance support. We had it before in OpenSIPS support in the proxy mode. And now we also have it for the back-to-back module. So when OpenSIPS acts as a back-to-back, it can provide information about this shared call appearance. And let's say that was like present, so what was about 1.11. I want to go briefly about what we plan to do for the next release. I think there are a couple of interesting things over here. So one of the most important things we are working on is quality-based routing. Because routing you can do based on prefix, you can do based on load, on whatever. But most important, in the next release, you will be able to do it based on the quality. And what's the idea here? You will be able to learn information about the quality of the calls to a specific destination. Like you are using a couple of gateways, right? And you will be able to collect on the fly information about the quality of the calls terminated to that gateway in terms of PDD, ACD, ASR, and so on. So there are different parameters. They are collected, and you can have an idea about the quality of that destination. And then your routing can take into account this information. For example, you can reorder your gateways to reflect quality. Like I want to, first of all, to try the gateway which provides the best quality. Also, you may use it for removing poor quality gateway. So at the moment, if there's a threshold exceeded, like quality is really bad, better take it off, right? So that's the easiest way to do. Or, as I said, you can change the order and prioritize all the time to good quality gateway.
Excuse me.
Yes.
Maybe this is obvious, but, and I'm an idiot. When you say quality, how are you defining quality?
Well, quality is defined, as I said, based on, there's a list of 6 or 7 parameters. Most of them, I mean, all of them are actually based on SIP signaling. So we are not collecting information necessarily from the RTP. Even so, that's something that we want to do maybe in the next step. Like, what's the delay in setup? What's the ratio in setting up calls? So you can learn about so-called
Okay.
quality from such.
So it's signaling based.
Yes,
Okay,
signaling.
that's-
And so that's step number one. Step number two would be eventually to get information from the RTP level, like perspective. But that's a bit, it's a bit more complicated. So we said, okay, that would be step two.
Only a little, right?
Sorry?
Only a little more complicated.
Yes. Okay, you have to start from somewhere.
Well, that's a lot right there.
Other things, actually this part is already done in the development version. We have routing data partitioning. We have a bunch of modules like dynamic routing, dispatcher, and dial plan, where you have to configure a lot of things about routing, like what are the destinations, what are the prefixes, and so on. And there are cases where you want to have multiple sets of such information, not only one. And these kind of multiple sets can be completely separate, let's say in the database, in memory, you can individually reload them and so on. So you have the ability to manipulate such partitions, such sets of data completely independent. Just to give you an example, with dynamic routing, you can say, yes, I have a set of data reflecting my routing to the database, like prefixes and pointing to a couple of databases, right? That can be seen as one partition. I can have another one used for matching inbound DIDs, right? So to recognize my own DIDs and to see who's the customer belonging to the DID. And again, you can use a dynamic routing module because it's still basically you can say a prefix equals DID matching. So you can have a separate partition. And even a third example, in the same configuration, you can have a completely different set of prefixes, not for the routing, but for the billing, right? So you want to do, let's say, kind of a postpaid billing. And you do, again, prefix-based matching, but not for the routing, but in this case, for putting a price on, so for the rate, it can be a completely different set. So one set for routing, one for the billing. Maybe you may have no relation between the two of them. So there is a strong need to have multiple sets of data for different kinds of purposes and to be able to work with them completely independent. So that's why for all these modules, we ended up defining partitions. Once again, they can reside in different databases, different tables. You can individually reload them. So you can, once again, completely independent manage. Something that might sound interesting, like fraud detection. So this is also something on the board. And it's fraud detection based on calling profiles. Basically, you define different profiles for in terms of calling. Like a profile may define may define like for a user what's the calling behavior. Like you may have some time intervals. What's the average number of calls in that interval? What are the number of parallel calls, simultaneous calls user should do in that interval of time? And also you can configure an let's say list of gray destinations. I'm not saying black and white, it's gray. You know, in terms of you can call there, but not too much, basically. You know, I mean it's okay to have let's say one call in that destination, but when you do like 3 or 4 times in a row, then there's something strange about that. So the idea, for example, you can have residential users, right? And you can learn the profile. You can define a profile saying, yeah, residential. Okay, they start calling, let's say, maybe 7 a.m. up to 10. Then maybe there is some gap when everybody goes to work, and then calling again in the evening, right? So whatever is out of this pattern may be abnormal, right? So you can raise a flag about potential fraud. Or the other way around, if you have an, let's say, corporate customers, well, they should be able to start having April. They normal behavior is calling from 8 to, let's say, to 5, 6 p.m., right? If you see that they start calling in the weekend, you have a corporate customer calling in the weekend, making like, I don't know, 10, 20 calls in the weekend, then automatically that's an alarm flag, because that's not normal, you know. First of all, it shouldn't be, it shouldn't fall in the weekend, and secondly, not with that rate, calling rate, right? So you can define such profile, you can assign the profile to a user, and then the system is just doing the detection and then reports when let's say a potential fraud happens, reports to you to let's say to a human factor to investigate. So it's not blocking, it's not taking any particular action. It's just reporting a potential fraud based on, once again, coding profiles. Then working on the SIP compression. And in this case, we have two kind of, let's say, compressions. One is more like SIP-wise compacting of the traffic, like trying to reduce, the whole idea is to try to reduce as much as possible the size of the package, just to, in some cases, reducing bandwidth, dealing with UDP fragmentation, and why not, let's say, optimizing the message in terms of parsing, so how the SIP message looks like, to be able to parse it as easy as possible. So there are a couple of simple things that you can do in order just to compact the message, like using short names for the headers, combining headers like with the same name, like via headers, route headers, and so on, or stripping out some headers that you decide that have no value, like you don't want to propagate like timestamp, subject, or maybe even user agent if it's not relevant for you. So in this case, the whole message will get shorter, right? And believe it or not, this fragmentation is a real problem, especially on the end user devices. You deal a lot with devices which are not able to, let's say, not to defrag, but to reassemble the fragments in order to build the UDP package. So that's one of the things, and the other one is actually doing compression of the message. Basically, you keep at the SIP side only headers which are relevant to the SIP routing, like maybe to the via, topmost via, and front header, call ID, CSEC, and that's it. The rest of the things, headers plus the body, can be compressed and added as a compressed body to the message. And this is very useful because you may have, let's say, large platforms where the same invite or package goes maybe 3 or 4 times to different OpenSIPS servers, right? You have an SVC, you have core system, then it goes maybe to another core server in a different location, and then goes again through an SVC out, right? So it goes through, let's say, 4 or 5 whatever instances, and all of them, they do have to parse that SIP message, right? It should be quite inefficient. So basically, all the unuseful information for routing can be compressed when the message gets into your network, can be compressed, attached to the message. So you have a very light format SIP message with a compressed payload which goes through the network. So you reduce a lot in terms of parsing. You don't have to parse all the bullshit attached to the message, which is not really useful for you as a proxy. It might be useful for, let's say, for the end device, right? So that's a quite interesting thing, once again, for the large platform. So it's just for the internals on the platform, it's not for the end user interaction. This one is for the end user, because that's standard SIP. But yeah, this is only a convention that you do inside the platform, so you cannot send something like that to an end device. And yeah, we have some ongoing work for asynchronous I/O operations at the script level, because lately this become a must in order to, let's say, to interface with other services based on different kinds of queries, like maybe HTTP queries to do caller ID, like CID nades, or maybe to do LMP dipping and so on. So you need to have the ability to not to block when doing such queries to external third-party services. So step by step, we are migrating the actual internals of OpenSIPS to get to design based on asynchronous reactor. That's quite difficult. I mean, it's not something that will happen overnight. But as a first step, as I said, we just want to be able to do something like that at the script level. So, and we have at the transport level some ongoing work to be able to, let's say, handle in a better way whatever is related to, let's say, connection-oriented protocols. In this case, TCP and TLS. Mainly it's about connection reusage, it's about the bandwidth, what's the policy on the timeouts in handling the connections. Also can be extrapolated for the, let's say, SSL level when it comes to the TLS, like what's the certificate to use with a certain peer, what's the policy about requiring or presenting a certificate, and so on. Currently, you can do all these, but you can do them in a global manner. So you cannot control it in terms of, let's say, per destination. And imagine that you may have TCP connections going to end users, and you want to have a specific policy in terms of that, and TCP connection in the backside going, let's say, to internal servers, and you have a different policy in how to handle such TCP connections. So that's why we want to do a dynamic way of configuring what are the attributes of how the connection should be handled, depending on, let's say, on the destination. So,
Excuse me, what is the Amazon you were talking about?
Mainly it's about running OpenSIPS in private networks. You know, like you run OpenSIPS in a private network, and you want to be able to talk via public internet to other services. Right? So there are a lot of things that needs to be done in order to, even if it sits in a private network, to advertise itself as a public entity. So to be able to talk via the public internet, with other partners, but still having access only to a private network.
I have one more question about this REST client you were talking about. You already have a module, REST client.
Yes.
Right?
Yes.
So you're saying that you're using that module. It's obviously it's blocking.
Yes.
Is that a good idea to use it that way, or I mean, how efficient that thing is?
Let's say it's about mainly how about the performance of the service you are querying. I mean, if you know that for sure the server will provide you an answer in a certain amount of time, you may say yes.
I mean, you get like you get the response back in, let's say, 50 milliseconds. Okay, and just open. In other words, my question is, by using this REST client, you guys pulling all those connections, or you just open and close it? I mean, what's going on the?
So how it works right now, you open when you do the script. Let's say when you want to do the query, it will connect the client to the server, so you send a request and wait for the answer. So between the request and the answer, basically that your script, that process handling your request, will block. You don't do anything, right? Which is basically waste of resources.
Like 50 milliseconds.
Yes, but considering that you can do like thousands of calls per second, right? That's 50 milliseconds. Means that in that time you could handle another, let's say maybe thousands of other requests that maybe do not require any kind of queries, right? Like a buy request or ACK or replies or whatever.
I mean, you're doing exactly the same thing to MySQL too. I mean, usually it takes like, I don't think it takes 1 millisecond to read the data from MySQL. Unless if you cache them internally.
Yeah, that's why I said in the very beginning we are trying to, because that's more dangerous when you do things from the script to third parties. Because typically, let's say SQL queries, you do it on to a local database. It's something that is in your control. So it's more trusted, I would say, right? Rather than going HTTP to a third party across public internet.
So REST client runs right on the same machine, for example. You don't need to go to
Server.
Right. It runs
Well,
on the same machine.
In this case,
Plus-
the risk is not so high, right? Because you have a very low, you have a very short round trip, and if it's here in your backyard, you can control it.
Yes.
So be sure that you don't have any kind of issues in generating, let's say, blocking for a long period of time.
Because we tested on this asterisk, same thing like a REST client, they use Grow. Actually, they go get
Yeah, it's the same.
I think same thing they use Grow. And you don't even get like 80 calls per second. It just like, you know, really slows down.
You have to, let's say, it's a simple math. Like, what's the typical time to answer from the server? Let's say you said 50 milliseconds. So basically you can do, what that would be per second, like 20?
Yeah.
Yes.
Like 200 is like 1 second.
Yeah, okay, that would be in one process. And you can configure your system to have multiple processors to be able to do as much of work in parallel. So to increase the overall throughput. Right? Then you can say, yeah, okay, I can get, I mean, by simply doing the math, you can say, okay, that's the maximum throughput I can get into these configurations.
Yeah. Unfortunately now you have to use those kind of clients. It's like nothing is, you cannot run everything on the same machine anymore. Like someone is running somewhere, you know, in China, you gotta go get that data, you know.
No, that's the whole idea, because anyhow the processing of the call will be delayed. Because you need the information over to complete the call, right? So you cannot go over that, but at least not to keep your resources blocked while you are waiting for the resource. So for a single call, nothing will be changed. From the call perspective, you have the same delay. But at least with an asynchronous behavior, OpenSIPS can do something else in the meanwhile, aside of simply sitting and waiting. Right?
Thanks.
Welcome. Okay, so now before closing, I have a short demo to show you about the call center. There's a small setup. Let me. Okay, I think I'll have to get out of this. Okay. So I have a bunch of CPPs here. What I'm trying to, the setup is like have an OpenSIPS in the middle. I simply injecting calls from the user agent client, CPP user agent client sending traffic into OpenSIPS, and then on the other side I have two user agent clients, one simulating the agents and another one simulating the queuing, so basically playing the media. So you see here I have the queuing. Yeah, actually it's not getting into, there's another tab over here. Let me see if I have to smart it. Okay, so we have the agents. So I will have here an CPP which actually receives a call, keep the calls for like 5 seconds and then hangs up. And after that, the agent has, it's configurable, set up as a 1 second wrap-up time for the agent before being again available for receiving. So overall, from a user agent perspective, a call takes like 6 seconds or 5 seconds, the call itself, plus 1 second of wrap-up time. So each client can do roughly one call every 6 seconds. So that would be the throughput of our client. Then I have here the queue. So the queue is simply, and the buying will be done by OpenSIPS, because OpenSIPS acts as a back-to-back region. So receive the call first, if it's the case, send the call in the queue, and whenever sees that there are free agents, will close the call, will buy the call to the queue, and then send the call to the actual agent. Once again, if there is no available agent from the very beginning. So that's the scenario for the queue, where it simply accepts any call, keeps the call on until a buy is received. This is the caller. You can see, let me scroll up a bit. So that's the scenario for the caller. Generates the invites or sends calls out, and it simply waits to receive. So the buying is done by the user agent server. So basically, in this setup, it's the agent, the one who hangs up the call after the 5 seconds. So the scenario is a bit more complex, because you may get you may receive some re-invites, from OpenSIPS when the call is transferred between the queue and the agent. So that's why it looks a bit funny, because the scenario may fork into either directly getting a buy or either getting a re-invite and then buy. Let me show you the web interface. Okay, so for the OpenSIPS running local, I just turn control panel, because first it's about configuring the call center. So in the call center, what I have here, let's start with the flows. So basically, flows are queues. We have the ID, we have a priority. Priority is used in distributing the call, because you may have an agent belonging to multiple queues in the same time. And calls coming into a flow with a higher priority will be inserted in the queue in front of calls which were received on a flow with a lower priority. Like in this example, I have like info and support. So like company have a separate queue for generic, providing generic information to, let's say, customers, or providing maybe, let's say, kind of an emergency support, so it has a higher priority to their customers. You may provide a welcome message, which is a simple CPRI, so pointing to a media server just to play back, like hello, it called, blah blah blah, whatever. And then you have a queuing message, so where to send. That's why I'm saying so we do only the SIP side. The media is provided by an external media server. So we are pointing by a simple CPRI to the media server. Basically, this one points to the CPP doing the queuing, right? So whenever there is, you don't have any free agents, you will simply send a call to that URI. And we have here the so-called skill. Each flow requires a certain skill from an agent. So for an agent to receive the call, the flow requires a skill. And this skill, it's does the mapping between flows and agents. Because if I look at the agents provide certain skills. So if the agent support provides info skill, then it will automatically receive calls from the info flow. In our case, these agents will automatically be logged in both queues, so it will receive calls from both queues. The other ones will receive only from the info queue. So the mapping is done. Yeah.
Will that also handle tiering?
Sorry?
Will the flows also do tiering? So like you have a tier 1 support person and a tier 2 support person?
You can define them as, let's say, different queues. You can define as many queues as you want, with different skills and different priorities. So that's the whole idea, to come up with a, let's say, system flexible enough to allow you to, let's say, to use it for different kind of setups. Okay. So, yes.
So would it be envisioned that there would be at some point an ability to set up these queues and agents and skills and the like as parameters through an interface that could be provisioned in a program, like on the fly? Or would it?
Well, the control panel allows you to provision, to define what are the queues and who are the agents, right? Let's say the only thing that you have to do in a dynamic way is to what is called logging in the agent to the system. So basically, the system should be aware that this agent is able to receive calls at that point. And that you can do it in two ways. You can do it directly from the script. You have a function like register agent, and you can do it automatically. For example, when the agent does normal SIP registration, so becomes online, you can automatically log in the user also into the agent into the call center. So that's a way to do it. Or you can do it via the management interface, and you can trigger it from external based on whatever you want to do there. So, you can have a web application, client agent gets in, clicks a button, and then you can log in via the MI interface. So it's up to you how to do that. But the idea is to have these two entities, the flow and the agents, which are connected by the skills. And in the statistics, okay, the OpenSIPS is not started, that's why you get this. Let me start.
Okay.
Okay. So now I have a bunch of statistics from the call center module. They have they can be like CCG, call center global. So you can have like what's the average waiting time, load, what's the number of distributed calls, abandoned, on hold, so different kind of information about what's going on inside. So these are the global. The CCA comes from the call center agent, and you have for each agent a set of statistics, like how many calls were received, abandoned by the agent, how many that were answered, what's the average call duration, and so on. And in a similar way, you have for the flows, for the queues. They are the CCF, call flows, and you have like estimated time to wait, average waiting time, how many free agents are for each queue, and so on. So if you have all the things in there, I checked for charting a couple of them, global ones, so we will be able to see them here. Okay, I need to and let's put some traffic. So I have my OpenSIPS started. I can check the agents. I have like 12 agents, and we can see that all of them are in state free. They can be in state free or in call or in wrap up. And now let's say, let's do 100 calls. There are 2 calls per second. And we'll see that some calls, you see 12 calls, we have 12 agents, so 12 calls were directly sent to the agents, and now the rest of them are actually getting in the queue. Because the agents are, all agents are busy. We do again this. You see some of them are in call, some are in wrap-up time when the call was completed. And we also can check also this So now I see that I have like almost 16 calls on hold. Load on the call center, it's calculated, you see it's almost like more than 200% load. It's calculated like how many agents are free, what's the average duration of the call versus on how many calls are on hold in the queue. Right now there are spikes, small spikes in 3 agents, so all of them are busy. And now probably the queue, see that probably the 100 calls were done, and there are like just a couple of them in the queue. We don't have any more new calls generated by the, let's say, by the callers, so the agents are simply consuming the calls in the queue. Load is going down, and right now all agents are again free. So just an idea to see, what happens inside the call center. Questions?
Are you going to share this script you wrote, or?
Actually, I can show you the whole script. It's the default script with only one line added. Just, I mean, it's. So it's. Yeah, I'm sure it's not so visible. Well, it's just a small thing here, like if it's an invite, then simply do CC handle call center handle call, and you give the name of the flow. Here it's written info.
Syntax off.
What?
Syntax off.
Okay. Right. Okay. So if it's an invite, you just have to call the CC handle call, and then that's it. Nothing more. The call center will do everything for you. So you just have to push the call into the call center, and you have to tell what's the name of the queue you want to put the call into. Of course, this may be a variable, the name of the queue, and the variable, let's say you can get it from the dynamic routing module, like you have prefixes pointing to different queues, so you can combine something like that. That's a simple example of the static queue.
How does it handle concurrency when distributing the agents? In other words, you got 5 agents that are able to take a call and one call comes in. Does it ring all 5 phones? Does it just go to
No,
one
it
agent?
will pick only one. Actually, it's trying to do a round robin, so not to abuse only one agent all the time, the first one.
So
But to do round robin, it will deliver to only one.
And if a call comes in behind that, does that then get locked up on that one agent answering the phone, or does that call go to the next agent?
Goes to the next agent. Let's say if there is an available agent for that queue. So as time as we have a free agent for that queue, it will go straight to a free agent. Only if there is no free agent, only then it goes to the queue and waits until the one agent gets free again.
How do you determine if the agent is free? By the number of sentences, or
we keep internally trace of call and agent, and when the call is done, we know that the agent is again, let's say, free.
Using the dialogue module.
No, it's actually we are not using the back. You're using the back-to-back, not the dialogue stuff.
Ah, okay.
Because we have to get the call, and let's say, more complex scenario, you have to play first a welcome message and then hang up and then go to the, let's say, maybe the queue and hang up and then go to the agent. And imagine that you may have the situation where the agent doesn't pick up the phone. It happens, right? So if the agent rejects the call, then you send to another agent, free agent, and so on until you are able to send the call. And if you do not, you have to go again and put it in the queue, you know. So for moving the call between all these destinations, it's based on the back-to-back module.
Can you use the JSON interface to set up the queues and?
To set up, no, in configuration, provisioning, in the database. Yes, so you have to put into the database. But you can get via MI, you can get a lot of information like list of ongoing calls in the call center, like the status of the agents, and so on. So all this kind of information you can fetch from the call center via MI and so on if you want.
But it would be nice if you would be able to fill up the database. You can fill up the database any other way that you want, and but you can reload it into the database using MI interface.
Yeah,
okay,
yeah.
So that's the thing.
Yeah, if you want to add like a new agent, so you can do reload without losing anything.
So I mean, you can use your own interface to fill up the database and just tell, okay, so right now this is a new. You don't have to use standard OpenSIPS web interface for provisioning.
That's an easy way just to show. You know, I could show you the database, but probably it's much easier to see it on the web interface rather than.
Definitely.
Okay. Other questions? Because otherwise I'm running
out. Do you
out
have any kind of tutorial about this? How it's working and about explaining this web interface?
There is the module documentation showing you maybe like 50-60%, because it's not so difficult. I mean, once you understand what you put in the database, as usage, you see it just calling one function. It's not a big deal. But I was planning to actually have a full tutorial about from A to Z on how to do that. So, but let's say the extra value of the tutorial it's not so huge versus the existing module documentation. Okay, so at least from my side, that's it. Thank you. I'm over with 30 minutes, so someone will kill me definitely. Probably you, because that means the lunch break gets shorter.
Ate up your entire